In this lecture, I will discuss about different analysis methods. Here, from the official website of CSI knowledge base, what type of different analysis methods, basic analysis methods. So first of all, non-linearity, that basically exists in two ways: geometric non-linearity and material non-linearity. When we apply the geometric non-linearity, we consider the p delta effects. Means if due to lateral force the extra movement deformation increases in the building, so we consider the geometric non-linearity. For the material non-linearity, consider the inelastic structural response in which the behavior of component, system or connection devices from the initial stiffness stringent characteristics of linear elastic behavior is used. So these are basically non-linear. So what type of basically analysis methods? That's a very good demonstration or brief demonstration about the analysis methods given by CSI. So here is a linear non-linear. For example, if we plot any steel material, the stress versus strain plots, and then we got two portions of linear and non-linear, means elastic behavior and inelastic behavior, or you can say elastic range and inelastic range. Similarly, that's the two different types I have discussed, linear and what is non-linear. And there is again two: static load and dynamic load. Static load is the load which do not change with time, and the dynamic load which the load which change with respect to time. In the static load, you can consider the load points which you applied in the form of values to the structure. And in the dynamic, you have to provide the whole history record, means the for example, the acceleration versus time, velocity versus time. So all these types of things that dependent on time, dynamic loading. So you can see there are four basic analysis types. First one is static, that is a strength based analysis. You may heard in the bachelor classes equivalent static analysis method or equivalent load analysis method. So this based on strength based. So that is a static method, means and another it's a in the elastic range or the linear range of the structure. Okay, so that is a strength based method. So about the strength based method, analysis is a static linear procedure in which structural components are specified such that their elastic capacities exceeds the demands of the loading condition. It's a strength based demand ratio indicates the adequacy of each component. So this method is a simplification of equivalent static load method. The second is static pushover method. In the static pushover method, we basically perform the plastic analysis, or you can say we check where the hinges will form, or we basically discuss in the both, in the linear and non-linear, in the both regions. So that is a static non-linear method, that is a static pushover method. The third one is the response spectrum analysis, that is a linear and dynamic, means it is in the elastic range, and further it's a dynamic analysis, means the load history of this analysis is also based on load versus time. Response spectrum analysis is a dynamic and linear method in which maximum structural response is plotted as a function of structural period for a given history of record and level of damping. Okay, so in this we apply the loading in the form of load versus time. In the time history record, we apply the full time history record. For example, in the previous records, the earthquake which came in the different areas in different cities, depending upon different conditions like soil, these types of conditions, we apply the time history analysis. That is dependent on dynamic and non-linear analysis, means it's work in the linear and non-linear range both, and further it's a dynamic, means the load also vary with respect to time. Okay, in the software there are two different methods: direct integration and fast nonlinear analysis, that we will discuss in later. First of all, I am discussing in this lecture the strength based method, that is a equivalent static load method. Each analysis type have its limitation. So first of all, strength based, or you can say in the lateral analysis, like equivalent static load method. Okay, here, equivalent static or pseudo-static load method. In this method, some equivalent static forces, means overall analysis is not applied, only the peak values are applied to approximately get the effects of vibrations according to the fundamental and higher modes of vibration. For example, that is a okay, here we will pick the zone factor. For example, in which zone area our building lies, so we will pick the zone factor. We will pick the soil profile, the near source factors, all types of things we will pick in the equivalent static load method. So there are limitations also of this method. The equivalent static method is only applicable if following conditions are satisfied. First one, all the structures in zone 1 and regular or irregular structures, but not for essential, hazardous or special use in zone 2. Means only the zone 1 structures, either of regular or irregular, are designed by equivalent static, but not for special, for example nuclear plants. All these types of things are not should not be analyzed if these are in the zone 2. The second condition, all regular structures up to 73 meters, means regular structures with any lateral load resisting system. It's a damping, movement, shear wall, any, but it should be regular. All irregular structures, regular structures is called, basically these regular or irregular, these structures are basically called depending upon the structural irregularities that I have discussed in the previous lectures, like stiffness irregularity, torsion irregularity, mass irregularity. So these types of irregularities in the structure, no irregularity should be present. All irregular structures up to only 5 stories or 20-meter height, that is very important parameter. If you are applying the equivalent static analysis, then any irregular building up to 5 stories or 20-meter height may be analyzed. Okay, the fourth one is, that's a somewhat maybe difficult for you, but you can adjust. Regular structures having a flexible upper portion, means the upper story is flexible, means have low stiffness over a rigid lower portion satisfying the UBC provisions. So these are the limitations of the equivalent static analysis. And how to apply this method, I have discussed how to apply the in the equivalent static analysis. You will pick the zone factor, soil profile, near source factors, all types of things. How you will pick these values, I have discussed in the lecture of defined gravity and earthquake loads. You can see my lecture of how to define the loads in this method. So after I have already applied the load, that is the equivalent static load methods. That's a earthquake X, earthquake minus X. These are equivalent static load method patterns. Here you will select the direction of load, means lateral load, and its centricity. That's a 5% centricity. Time period building will calculate. Okay, how from which story to which story the load will apply, that is our strength factor. All these types of I have discussed in the lecture of defined gravity and earthquake loads, so you can see from there. Okay, similarly this okay. So now I will run analysis and then I will run design. I want to again assure you that The equivalent static load method is an approximate technique, and before applying you should or you must know its limitations. Okay, you should never bypass its limitation. It has limitations. Then the for more high buildings you can apply the response spectrum or the time history analysis. Okay, because time history analysis is applicable to any building, so we will discuss also in the next lecture how to apply the time history also. Now you can see the display, for example, a deformed shape against the load earthquake plus X apply. Okay, here you can see the deformed shape due to the lateral earthquake record, not the earthquake record, basically earthquake load parameters according to equivalent static load method. Okay, you can again see the against the combinations, any combination apply. Okay, in the combination have been generated by the default option. Here at default design combination you can see in the combinations earthquake parameters are considered. Here earthquake minus X is 1, okay, minus y, okay, minus 1. So all load patterns have been generated, load combinations have been generated. Okay, now I can see the deformed shear forces, bending moments, frame. For example, I want to see against any combination the moments of this structure apply. Here you can see the moment values of all the frame members have been displayed. Okay, why not the shear wall forces, that is the shell members. So for that we have to go into the shell forces. Similarly, if I want to see the shear forces of all the structure, here are the shear forces of all the structure. You can click on any member and you can see the details. For example, here I am zooming and clicking this beam. Right click, you can in the detail see the forces. Here is the shear force. You can move from left to right at any point. Software will give you shear force, moment value and the deformation. Or you can say just show me the peak values. Here the maximum shear, maximum moment and maximum deformation. Again you can see against any load combination, load pattern, you can see. When the software goes for designing, software automatically pick the peak value for the design, for the means peak shear value, peak moment value for the design from all these combinations, and then go for design. Okay, so that's how you can see the forces. And in the shear walls, in the shell elements, how you can see, you have to go display, okay, shell forces. Here you can see against for example you want to see moment maximum, okay, apply. Okay, the slabs is also shell elements, and the how much moments in the slabs, or all these values now start appearing in the shell elements. So similarly you can also see the shear forces, axial forces, all types of forces in the shell elements. Now I have shown the analysis results. Now I will go into design, concrete frame design. Okay, here you will see the view/revise preferences. According to what design code I am designing the building, that is the ACI 31814. That is a step-by-step design. Number of interaction curves, for example for the column definitely we require the interaction curves, that is 24. Number of interaction points on the interaction curve, consider minimum centricity, definitely yes. Seismic design category, that is based upon in which area of earthquake zone area your building is present. You can also study the seismic design category. Design system omega 2. So how you can see this value, that is basically our strength factor omega. So for example, if you are designing moment resisting frame or intermediate or ordinary moment resisting frame, so for all types of structures, here AS is 16, here in the 12th chapter, just rotate the page. Okay, here the response modification factor we have used 5.5 depending upon our structure type. Deflection amplification factor, that is also I have shown in the previous videos, but the over strength factor we have not used up till now. So here for example special moment resisting frame, that is the value 3, and for intermediate moment resisting frame the value is also 3 for the over strength factor. So here you can put the value 3. Okay, so that is a system design system raw, design system SDS, okay, they consider ISCC. Okay, then the rest of the parameters are for example you have used in your for example in your academics when you do for the moment design, then you will use 0.9 factors. So all these types of factors are present for tension control, compression control, okay, shear. So these are the preferences. You have to must look into the preferences that set as per your requirement or not. Then for the concrete frame design, okay, you can also select the bar rules. For example, what type of bars you prefer for the design. Okay, smallest bar for example 12, highest bar maybe 25. So that's a requirement you can also see for ties, okay, depending upon your requirement. But at the start you do not need to look this, just rebar selection rules for beams and columns. Then select the design combinations. The software have defined all the design combinations are present here. You can also pick this one, but that is also present in the ultimate design combination 1. For example, you can see 1.4. okay, so that's how you will select all the design combinations. Now again you will just press start design / check. Software will also design and also check that all the members are okay against the loadings. Okay, here I will click start design / check. Okay, now the design is complete. The longitudinal reinforcement is appearing on the beams. Okay, so before checking, for example, here in the beam there are at 3 locations top and bottom reinforcement is appearing. So here that is in millimeter square. Okay, for example you will right click, that is a top steel, bottom steel and shear steel. Okay, and this beam is going to fail in the shear. Okay, that's why its color is red. How many members are failing? Okay, for example you can also see there is some red, more red members are appearing. So we have to see in the design, concrete frame design, verify analysis and design section is matched. That is used mostly in the auto list or in the steel frame design. But now we will check this option, verify all member passed. Here the software is saying that 78 concrete members failed the design check. Do you want to select them? Which members are going to fail? I am selecting yes. So software has selected all those members here. I can see view, sorry, okay, software is selected, and now I can uncheck the model, and then we will just click view the selected objects. I can see the all the objects which are failing in the design. Okay, means its design capacities are low either in the shear or either in the moment. Okay, so now we will revise the sections and again run the analysis and design. This procedure will repeat until all the members are passed. Okay,